In this equation, we have multiple logs going on, but there's still, everything has got a log on it, and all those logs have the same base. So we're actually not going to have to change forms. We are going to still use the idea that if we have log base A of something equal to log base A of something else, then these inner things have to be equal. But the problem is we have multiple logs going on, and we need to have just one log on each side to set these inner pieces equal to each other. That's where the properties from previous log units come into play, and one that I hope you remember is that if all the bases match, and we have log of something plus log of something else, you can rewrite that as multiplying these two things together. Basically, addition is going to turn into multiplication. It's kind of like a rule for exponents that we have, but kind of in reverse. And it should make sense because I hope you're seeing how logs and exponents are related to each other. So if we have rules like, a to the m times a to the n equals, make that an addition, it should make sense that there's a similar rule for logs, but a little bit different. And the difference is when you see addition, it turns into multiplication. And so for a problem like this, I'm going to see these guys with the big fat plus sign in between them. I know I need to condense that into just one log expression. So it'll be the natural log of, and I just want to have one thing inside of here. And since this was an addition problem, that will turn into this thing multiplied by this thing. So I'm going to write that right now as 4 times x plus 9. But if you were inclined to write 4x plus 36, that'd be totally fine too. Not a problem. And then, of course, the right side, there's nothing to do. It's just the natural log of 3x minus 1. So as I move on with this, I do have just one single log on both sides. They do have the same base. And the only way these can be equal to each other is if these inner pieces are equal. So at this point, I'm just going to drop the logs completely and say 4 times x plus 9 has to equal 3x minus 1, and this is great. This looks like something I did in Algebra 1. I'll distribute the 4 to get rid of the parentheses. I will collect all of my x's to one side of the equation. I will try to keep my coefficient on x positive, so I'll subtract a 3x from both sides. This would cancel if I subtracted 3x, and then 4x minus 3x is just 1x, giving me x plus 36 equals negative 1. And now to get this x by itself, I will subtract 36 from both sides, giving me x equals negative 37. This seems like a good answer. It seems okay. But the other thing we have to worry about for all of these log problems is making sure that our answer doesn't make us take the log of a negative number. So if I go back to my original problem with this negative 37, and I plug that in here, negative 37 plus 9 is going to be a negative number. I can't take the natural log of a negative number. It's not allowed. So that means that even though this would be right, it doesn't actually work. I can't use it. This equation is no solution. And that's what I'd have to report to make sure I got, full credit or demonstrate my full understanding. This may seem like a lot of work, but basically we're just going to be, condensing. So if you can keep in mind that addition turns into multiplication, then that'll be helpful. And then because there's a log on both sides and just one log on both sides, we can just simply set these equal and go from there. So hopefully it's not too bad. Good luck.